Right, so this is the project that I just presented before. It's a project that finished, and this is, let's say, the current ongoing project. And this is about, again, low-cost industrial IoT-oriented digital development. So in this case, what I'm going to go through is the different deliverables that we have here, which the first one starts with technology classification. So basically, previous project was looking at how you do a rapid development for demonstrating the use of low-cost technologies. But obviously, it's a question of how do you choose the technologies and what's the best way to put them together, how to visualize them, collect them, sort them, etc., etc. And there are other two deliverables. Obviously, we are not there yet. One of them is in particular being developed as I speak, and it's all about having another demonstrator. So let me just go through the first one. So as in the previous project, this also comes as a support for a bigger one. And this is all about how you build solutions. So for instance, solution I showed before, the way we came to there is because in that big project, we have something which is called solutions requirements. And it's all about running workshops with SMEs and looking at which are the first or the best needs or the urgent needs for digitalization. And once these requirements are assessed and ranked, then there is a conceptual modeling that's part of the shoestring project that tell us how to build solutions in a modular way, if you want. And obviously, at one point, you need to realize that modeling, and for that, you need the right technologies. When I say the right technologies, we need to say, why am I using Raspberry Pi and not a different one? Or if someone is using this, let's say, modeling technique, has to be aware of other alternatives that can help person realize the modeling. So that's where it comes the identification and classification of these low-cost technologies, and that's where my talk is going to be about. So in this case, probably there are three research questions I wanted to go here, and the first one is, how could we group technologies that we need? And one of the ways we solve this question is arranging these different elements of conceptual elements of modeling that we have in the shoestring that we call services and building blocks. And I'm not going to go in detail today, but that literally gives us if you want, a map in our mind to understand what elements of data collection are out there and how can I group them together. Same for user interfaces, actuation elements, computing hardware, and data analytics, etc., etc. So that having this picture in mind, then we start looking at the technologies that we need for, let's say, associating to each of these boxes that you see in the leaves. And then you come to the point where you say, but how do you classify them? So how do you put them out there for someone to choose without going into the, let's say, nitty-gritty technical details of a technology? So this has to be a kind of a higher level of classification and search that we could provide to the end user. So for doing that, we use a framework or an algorithm that someone has been using this for different other domains, from blockchain to problems in industries, etc., etc. And this basically gives you an approach to define domains and characteristics, either from empirical to conceptual way, or from the conceptual to empirical. And this gives you as a result a table like the one that you see at the bottom left, while on top of the top column, basically, the top row, sorry, basically tells you the domains, and for each domain you have different characteristics. So if, well, probably, sadly, this is not that big, at least not on my screen, but if you can see the first column where basically you got different sensors, and then the green dots will tell you whether each sensor ticks different characteristics. And that's the type of classification that we are looking at. And obviously, there's another question regarding of how you capture these technologies. And is there any systematic way of doing this? So we are looking at technologies that we know and we use, but we are also looking at those ones that we know but we don't use, and the other ones that we don't know. And most important is the emerging technologies. So there are different approaches out there. One of the most well-known approaches, or that generally people are using, is defining suitable query strings for browsing the internet, manually querying 3 to 4 web repositories for research or white papers, scan the technologies appearing in those papers, and then reclassifying as they go through the scanning of citations of those papers. So this is an example of that that has been used for Industry 4.0 technologies. But one of probably the outcomes that we've been seeing is that the results are usually in general technology terms. So it might say single board computer, but it doesn't tell you Raspberry Pi or Beagle, which is probably the actual product or the technology that we are after. Okay, so and that's one of the ways to do it. And another alternatives are out there. Other kind of bespoke approaches that we are using is starting with known or current technologies that we know, and then looking at alternatives of them. And with those alternatives, then doing different queries to repositories or technology comparison websites or industry suppliers. And if that somehow meets the requirements of the type of technology we are looking, then we start looking for similar of those ones. And another alternative is obviously doing a bit of crowdsourcing, for instance, through a portal or through different specialists like industrial partners that we have in the project. Some of them are solution providers, so we can also feed from them. And in order to have a tool and realize this deliverable, if you want, what we are doing is putting all this classification, and you can see again the example in terms of data storage in the bottom corner. We are putting all this into a database, and the database has let's say the realization of this classification, and also some other added like metadata, etc., and that is put online in the form of a REST API, if you want, that gives us a result, a JSON. Basically, this JSON is giving you a result of a query of this classification that this different part of the project is another tool that fits from this JSON and helps the user realize that conceptual model for the solution. And obviously this works all together because we have also for filling this table, we have the other part that is going out there and capturing the technologies. So there is this kind of a two model engine here, looking at technologies, feeding into this classification, and then as a result, feeding into into a tool that the user uses for doing the demonstrators. And yeah, so I think here is where I finished the second talk, if I'm not wrong. Yeah. So I'm happy to take questions. I know that the time is not in my side. So Alexandra, back to you.
Thank you very much, Herman. Does anyone have any questions for Herman? Okay, I had just one. Will the database and the taxonomy that you're creating here be made available to public?
Yes, that's the idea. That will be available for the public, and hopefully will also feed into other research projects. And most importantly, hopefully will also feed back to us when other projects or the public uses this. Because I think there should be a way to help or to find the technologies existing out there, and especially the emerging technologies. Usually, you get to know emerging technologies when they are in the highlight of the news, right? When they appear, I don't know, in Amazon or in a YouTube channel, saying, "Oh, this is a new thing," and people start using, or by influencers. Probably bringing influencers is also a good idea, but just something from my mind only. I think it's another question around, or probably not.
I think there's one more question. We're probably going to be quite 5 minutes late for the other presentation, but Ticia is asking.
I don't know, it's not an important one. It's something that I think Herman and I have had the exchanges in the corridor when we still were at IFM, that there is a lot of sensing, but the actuators part is really, I don't know if they exist. I was looking for some for the house for turning things on and on, and on and off, and I realized there are very few. And I don't know if something that is coming along or is not.
Yes. So in terms of actuators, one of the demonstrators that is in the other project is about how can you actuate with your voice. And so if you want to speak, let's say, to a machine, how is there any way that the machine connected to a PLC will do something after you talk to it? And it's one of a nice demonstrator where it integrates another off-the-shelf solution, which is an Alexa, an Amazon Alexa in this case. And you basically talk to that, and it's a chain of elements in there, but at the end of the
packages,
chain, yeah, the PLC does what you need. That's one of them. And then I need to think another ones that we probably had, but yeah, probably in that respect, we don't have as many actuation solutions as I remember now. But no, it's a really good point. And yeah, this map of technologies in particular, we had some of them related to actuators, but probably we need to revisit it to complete.
No, it's just, if something comes up, let me know. I'm interested.
Yes, absolutely. Thank you.
Cheers.